Okay, in this question 2, we've got to prove an identity. Okay, now proving an identity means we need to show that this expression is always the same as this value, this expression, whatever the value of a. Okay, so we've got to always prove that a left-hand side is equivalent to a right-hand side. And the normal way of doing that is to start with either the left-hand side or the right-hand side and work through lots of equivalent steps and end up with the other one, the one you didn't start with. It's fine to start with the right-hand side and work towards the left-hand side. Okay, you can do it either way round. It's not ideal to start with both sides at once and work towards the middle. And the first thing you must avoid is you must never write down this expression as your first line. Okay, you start with either the left-hand side or the right-hand side, and you don't assume those two things have anything to do with each other until you've actually joined them up. So I'm going to do it the simple-minded way, starting with the left-hand side, which is tan of a plus sec of a. And I'm going to notice that what I want to end up with only has got sine a and cos a in it. So one good strategy sometimes with trig is to turn all the trig functions into sine a and cos a. And we know that tan of a is sine a over cos a. And the definition of sec a, third letter is a c, so it's a reciprocal of, it's 1 over cos of a. So the left-hand side is tan a plus sec a, which equals this. And now I've got a common denominator of this fraction. So I've got a cos a on the bottom. Okay, and on the top I've got sine a plus 1. And if I look at what I'm aiming for, this is exactly the same. Now the top's written, the addition's written the other way around. But I don't even need to write it out in this final form. You can. This is optional. 1 plus sine a over, sine a over cos a, if you want to end up with exactly what they had. But you could get away even without writing this bit down, but you must say this equals the right-hand side. And we need to then just do a little bit more. In a proof, we need to very clearly reach the step where we've said we have finished. So you might write as required after this. Okay, I'm actually going to write, therefore, left-hand side equals right-hand side as required. That's completely watertight. So at the end of any proof, you need to have some kind of statement that you have finished off the proof. You need to claim, point out that you have proved what you set out to prove.